Hello everyone, I'm your friend Shadab Imam and currently we are dealing with the topic of CPM and PERT. In today's lecture, we are going to see another very important topic of crashing in network problem. So let us first of all understand what is crashing. Crashing is basically compressing the critical activities, and by compressing we mean that the duration of the critical activity is decreased, and as a result the duration of the overall project is decreased. So before we move ahead with crashing, we must understand that any project consists of two types of cost: direct cost and indirect cost. And the cost that directly depends on the amount of resources involved in the execution of an activity are direct cost. For example, the cost of material, cost of equipment, cost of labor. And the indirect cost depends on the duration of the project. And here in crashing we assume that the indirect cost linearly depends on the project duration. So if the project duration is small, the overall indirect cost is small, and if the project duration is large, overall indirect cost is large. Now let us move on here, and we must analyze that in our network problem the costs are not expressed in terms of direct and indirect cost, but instead it is expressed in the form of normal cost, crash cost, and indirect or overhead cost. So the normal cost is the direct cost which an activity incurs in normal time. So here is the normal cost which an activity incurs by completing in normal time, whereas a crash cost is the increased form of direct cost. So this is the crash cost, this is the increased form of direct cost which occurs when the activity is completed in crashed time. And what is a crash time? Crash time is the minimum time in which an activity can be completed. So we can see here in our problem we have two types of time and two types of cost. First is the normal time, where an activity can be completed under normal circumstances or taking normal time, whereas crash time, that means an activity must be needed at least this time, this much amount of time to be completed. And by going on crash time we will have some increased cost value which represents the crash cost as compared to the normal cost when the activities are completed in normal time. And the overall or indirect cost, the indirect cost or the overhead cost are the cost which depends on the project duration only. So let us understand this, how to solve this problem. So let us move on to the problem, and we can see that in order to crash an activity we must find another component or another variable which is known as cost slope. Now let us understand what is cost slope. So the cost slope can be represented by the formula Cc minus Cn divided by Tn minus Tc. So this is the difference between the crash cost and normal cost divided by the difference between normal time and crash time. So basically we need the difference between the two costs, crash cost and normal cost, divided by the difference between the time, that is normal time and crash time, or simply we can show them as delta C, that is change in direct cost, or divided by delta C, change in time. So by this we get the value of cost slope, and the cost slope shows the potential increase in the direct cost per unit time if the activity is to be crashed. So we can see that if activity A is to be crashed, when we calculate this cost slope we will find the increase in the slope when the activity is crashed by 1 day. So let us calculate cost slope for various activities here. So delta C is 4000 minus 3000, 1000 divided by 1. So this is 1000 per day. Now for activity B, it is 2000 minus 1200, that is 800. 800 divided by 4, so this is 200. This is 1800 minus 1000, 800 divided by 1, so this will be 800. This is 2000 minus 1200 is 800. 800 by 2 is 400. Similarly here 16 minus 1600 is 0. So it will not have any cost slope. So we have calculated the value of cost slope, and as we can see that if activity A is crashed, we will increase the direct cost by rupees 1000 per day. If activity B is crashed, the increase in cost, or we can say increase in the direct cost, is rupees 200 per day, and so on. So we have seen the basics we need to calculate the values or to crash the activities in crashing. So let us start solving question. So our problem here says that consider the following activities for a project where activity A precedes all others while activity B must follow others. Apart from this, activities can run concurrently. So here it has been shown that there are 5 activities, and it says that activity A precedes all other activities. That means activity A should be completed before starting any other activity, and then it says that activity E must follow others. So it says that activity E is the final activity, and after activity E is started, no more activity can be started. So, and the remaining activities can start concurrently. That means they can work parallelly. So let us first create the network diagram here. So let us start here. Activity A. So let this be activity A. This is activity A. Now as we can see that activity B, C and D can be start only when activity A is completed, because it is mandatory, and after that these 3 can start concurrently. That means they can start at the same time. So let this be activity B, let this be activity C, and let this be activity D. So now we need to draw the final activity, and this activity succeeds all other activity. That means if all the preceding activities are completed, then only activity E can be started. So what we will do is we will terminate these activities here, and to show the dependency we will draw 2 dummy activities. This is DM1. Similarly this is DM2, to show the dependency of B and D at C. So at this particular node we can see that activity C is completed, activity B is completed through this dummy, activity D is completed through this dummy. So we can start activity E here, and this activity E is finally completed. Now let us mark the events here. This will be 1, 2, 3, 4, 5 and 6. Now let us see how we can show the normal time and crash time for these activities. So we need to follow certain representation. We will write this as normal time, that is 5, and in bracket we write the crash time, that is 4, comma, the cost slope is 1000. Now for activity B, normal time is 6, crash time is 2, and the slope is 200. Similarly for activity C, normal time is 4, crash time is 3, and the slope is 800. For activity D, normal time is 5, crash time is 3, and the slope is 400. For activity E, normal time is 3, crash time is also 3, and the slope is 0 or nil. Now from here we can see that we have different time zones for different activities. Now what we will do is we will calculate the various path and we will show their completion time. So various path, so as we can see that there are 3 possible paths here: 1, 2, 3, 5 and 6, 1, 2, 5 and 6, and 1, 2, 4, 5 and 6. So let us write here. First is let this be activity A. Okay, so this will be activity A, B, DM1, that is dummy 1, and E. Similarly, second is A, C and E. A, C and E. And the third is A, D, dummy and E. A, D, dummy and E. Now let us find out the normal time completion of these 3 routes. So this is the normal time. So for the first route we can see that here is the normal time 5, 5 plus 6, 11, 11 plus 3, 14. So we can see here this is coming as 14 days. So this is 14 days. Now the second route, this is 5 plus 4, 9 plus 3, 12. So this route is having 12 days. Similarly the third route, 5 plus 5, 10 plus 3, 13. So this has a duration of 13 days. So as we can see here that this route A, B, dummy and E is having 14 days, which is a maximum time. So our critical path is this. Sorry. So we will write here the solution of the first part is to find the critical path, and critical path is the longest duration. So this will be our critical path. So I am writing here A, B, dummy and E, which is equal to 14 days. 14 days. So first part is completed. Now we are solving for second part, and simultaneously what we will do is we will calculate the total project cost. Now what is the total project cost here? So we know that project cost is equal to the direct cost. That means for normal time we can see that this is the direct cost for various activities, and this amounts to 8,000. So the direct cost here is 8,000 plus, as we can see the third part, it says that if the indirect costs are rupees 300 per day, determine the optimum schedule. So indirect costs are rupees 300 per day. So we know that the critical path is for normal time is coming as 14 days. So we will have the indirect cost for 14 days. So 14 into 300. So as of normal time we will have this rupees as our total project cost. So we will write this value here, and as we crash the activities, we will simultaneously be calculating the total project cost and writing it here. So for normal time, we will have the cost as 12,200, that is 12,200. Now I am just erasing this just to calculate other values here. Now as we can see here, this is the critical path, and we will try to crash the critical activities here. So first of all, let us see for first crashing. So this is the first crashing, and we are crashing the path A, B, dummy and E. So as from here we can see that we can only crash among these two activities, because activity E, for activity E, the normal time and crash time are equal. That means this activity cannot be crashed further because these two times are equal. So we will show it in this form, which represent that no more crashing takes place in activity E. So as of now we have two activities between which we need to select. So we will see the cost slope here. So cost slope for A is 1000, for B is 200. That means the value of increase in the direct cost is rupees 200 per day, whereas for activity A it is rupees 1000. So we will definitely going for the lesser slope, or we will select the activity B for crashing. Now as we can see that our critical path is having 14 days and the other two paths having 12 days and 13 days. So we can only crash this activity for 1 day, so that it became equal to this 13 day. If we crash it for more than 1 day, then our critical path will be changed and our solution will become complicated. So what we'll do is we will crash activity B by 1 day. Why we are doing it by 1 day? Because we can only crash this critical path for 1 day, as there is another path having 13 days as project completion time. So crash activity B by 1 day. So crashing this activity, that means now this activity will have 5 days instead of 6, and now we will calculate the new total project cost, and the new total project cost can be given as the previous cost is the normal time cost. Okay, so before first crashing we have considered the normal time for total project cost. So previous cost is, according to here, is this 12,200 plus the increase in the cost, that is the crash cost. So we can see that this crash cost can be calculated from slope here. So the slope is 200, that means this activity is crashed for 1 day, so this will be 1 into 200 minus of indirect cost, So here we can see that as we are crashing the activity, the duration of activity will be reduced, and as per the duration the indirect cost is calculated. So we can see here what will be the new project cost. The previous cost here is 12200 plus crash cost is, slope is 200 into 1 day, because this activity has been crashed for 1 day, minus indirect cost. We know that indirect cost is rupees 300 per day, so 300 into 1, because it has been crashed for 1 day, and this cost for 12,100 rupees. So now after crashing this, we will see for first crashing, what are the time for this path. This will be 5 plus 5 10 plus 3 15 5 plus 5 10 plus 3 13, so this will become 13 days. And A, C, E, because there is no influence of B, so it will remain as it is 12 days, and this will remain as it is 13 days, because activity B does not affect these two. And the total project cost we have calculated here is coming as 12,100. 12100. Now again let us move on to second crashing here. So let us move on to second crashing. This is second crashing, and for second crashing we will see that we have two critical paths here, because the time of these two paths are same and this is the maximum time. So here there are two critical paths. So one is A, B, dummy and E, and the other is A, D, dummy and E. Sorry. So we will see that what is the minimum slope that we can select for the activities. So as we can see here, if there are two critical paths, we need to select the activities to be crashed. So if we select activity A here, which is in both part, so if we select so let us say first part is having critical activity A, B and E to be crashed, and the second path has critical activities at A, D and E to be crashed. So if activity A is crashed, it will have the slope of 1000, and if activity B is crashed, then we need to crash activity D also, because then only both the duration will be reduced, otherwise the critical path will not reduce, that the total time duration of the path project is not reduced. So if A is reduced, then A is in both the path, so we do not need to do anything else. So if B is reduced, then we need to reduce D also. So let us see here, if activity A is crashed, the crash cost, or we can say slope, is 1000 per day. If activity B plus D, because if B is to be crashed, then D is also to be crashed. The crash cost here is, for B it is 200, for D it is 400. So 200 plus 400 is 600. So here also we can see that crashing these two activities will giving us less value of slope as compared to crashing activity A. So we will select to crash activity B and D simultaneously, and for activity E we have already seen that no more crashing can be takes place in activity B here. So I am just erasing this. I hope it is clear. Now as we can see that the other time is 12 days here, so activity B and D can be decreased by 1 day only. So crash activity B and D together for 1 day. So as now activity B and D are crashed together, this 5 will become 4, this will become 4, and this 5 will become 4 here. Now let us calculate the new total project cost. So new total project cost is the previous cost plus crash cost plus minus indirect cost. So the previous cost here will be this first crashing cost. Now this will be 12100 plus the crash cost. As we have seen, if we crash activity B, slope is 200. If I crash activity D, slope is 400. So if we crash them together, the slope will be, or crash cost will be 600 per day. So this is 600 multiplied by number of days. So we are crashing for 1 day, minus indirect cost, that means 300 multiplied by 1 day because it has been crashed for 1 day. So this will become 12400 rupees. So here I am writing this here, second crashing, the activity, this activity has been crashed. Now the timing here is 5 plus 4 9, 9 plus 3 12. Similarly here it is 5 plus 4 9, 9 plus 3 12. So this has become 12 days. This is also 12 days because B and D does not affect the path A, C, E, and this is also become 12 days. And the total project cost has become 12400. That means this is 12400. Now as we can see here that all the three paths are having the same value. That means we need to crash an activity, or we need to select the activities to crash from each of these paths. So if we crash activity A, then path A, B, E will be crashed, A, C, E will be crashed, A, D, E will be crashed. If we crash activity B here, then activity B, activity C and activity D together we need to crash. Okay, because if we crash activity B only, then this path will have 12 days, this path will have 12 days. So it will not affect the overall project duration. So if we crash activity B, we need to crash C and D also. If we crash activity C, we need to crash B and D also, and same is the case with activity D. So let us see what are the cost here. So let us see, for if we crash activity A, for activity A, the slope is, or we can say the crash cost is rupees 1000 per day. So for activity A, it is 1000 per day. And if we crash B, C and D together, if we crash activity B, C and D together, the crash cost will be 200 plus 800 plus 400. So this will be 1400. So as we can see here, crashing A will give us lesser crash cost as compared to crashing B, C and D together. So here what we will do is, we will crash the activity A only for and we'll see that here activity A can be crashed for 1 day only, because the crash cost is 4 and the normal crash timing is 4 days and the normal time is 5 days. So that's why activity A can be crashed for 1 day only. So crash activity A for 1 day, and this is the third crashing. This is the third crashing. Now when we are crashing activity A, this will become 4. From 5 it has become 4, and once this has become 4, then the crash time and normal time will become equal and no more crashing will be possible after this. So we have shown this in this form so that it is clear that no more crashing can be possible here. Now let us calculate the new project cost here. So it is the previous cost, which is equal to 12,400, 12400, plus the crash cost for activity is 1000 into number of days 1, minus indirect cost is rupees 300 into number of days 1, and here this will become plus 700, 13100 rupees. And after third crashing, let us see the time again. This is 4 plus 4 8, 8 plus 3 11, so this is 11 days. This is 4 plus 4 8, 8 plus 3 11, so this will also become 11 days. Here it is 4 plus 4 plus 3, it is 11 days. So again we are seeing that all the three parts are now having the time of 11 days, and now we will have only activity B, C and D for crashing. So if we crash activity B, we need to crash C and D also. If we crash activity C, we need to crash activity B and D also. If we crash activity D, we need to crash B and C also. So let us see for how many days we need to crash this activity B, C, D together, because we cannot crash activity A, we cannot crash activity E, and if any of these activity has to be crashed, then the other two must be crashed. Otherwise the project duration will not change, the overall project duration will not change. So now let us see here the normal time is 4 and crash time is 2. That means activity B can be crashed by 2 days. Here activity C can be crashed by 1 day. Here activity D can be crashed by 1 day. So basically we can crash these three activities together by 1 day only. So for fourth crashing, we will crash the activities. Okay, let me first write the cost here. It is 13100. Now let us crash activities B, C and D together. So the previous cost, so let this be first 3, let this be 3 and this will become 3. So once again the timing has been changed from 4 to 3, 4 to 3, 4 to 3. Now let us calculate the total project cost here again. The previous cost is 13100 plus the crash cost. Crash cost here is the summation of all the three cost slopes. Sorry, This is 200 plus 800, 1000 plus 400, 1400. So this is 1400 multiplied by 1 day, because these activity are crashed together for 1 day, minus indirect cost is 300 into 1 for 1 day. So let us see here, this will be 35, 45, this will be 14200 rupees. So here after fourth crashing we can see that this is fourth crashing. The duration of A, B, E is 4 plus 3 7 plus 3 10. So this is 10 days. For ACE it is 4 plus 3 7 plus 3 10 days, and here for ADE is 4 plus 3 7 plus 3 10 days, and the total project cost is coming as 14200. So as we can see now, the critical path has been reduced to 10 days here, and now as the normal time and crash time for C and D are same, that means activity C and D cannot be crashed now. So once these activities cannot be crashed, that means the critical path or the time for critical path cannot be reduced further. That's why we will stop the crashing activities here, and we will see the minimum duration, because it has been asked that crash the network fully to find out the minimum duration. So whenever it has asked to find the minimum duration that we can achieve for this project, so we have find out that after 4 crashing the minimum duration to complete this project is 10 days, and the corresponding cost is 14,200 rupees. Now let us see the third part. If the indirect cost are rupees 300 per day, determine the optimum schedule. Now whenever it has asked for optimum schedule, it will say for minimum cost. Whenever it has asked for optimum schedule, that means we need to see minimum cost. So we will see among all these crashing, the total project cost is minimum. So we can see that the total project cost is minimum at first crashing, that means here, where the cost is rupees 12,100. So we can see that the optimum schedule is when only activity B is crashed. So in first crashing we have crashed only activity B by 1 day. So if activity B only is crashed by 1 day, then we will get our optimum schedule with the project completion time as 13 days and the total cost as 12,100 rupees. So I hope this is clear. So it is a very important topic. If you find it useful, please like the lecture and share the lecture. Have a nice day. Thank you.